In my earlier video, I had discussed some question of linear transformation and matrix representation which had come in different type of competitive exam as a CSR, NET, GATE, NBSM. Today I will discuss one more question. First question which had come for 2020 exam. The question is very interesting and basic. The question is, let n be positive integer and the vector space V equal to set of those f belongs to Rx such that degree of f less than equal to a. Where is B a real vector space of real polynomials of degree at most n? Then endomorphism R over the vector space V denote the linear transformation from V to itself, and for M belongs to Z, let Tm be this endomorphism of the vector space. Here the field is real. Tm fx equal to f of x plus m, which is defined for all f belongs to V. Then dimension of the vector subspace of this endomorphism given by, here the vector subspace is denoted as span of the set Tm where m belongs to Z. Option 1, option 2 n square, option 3 n, and option 4 n plus 1. That means we have to find span of Tm where m belongs to Z, and here the mapping is defined as Tm fx equal to f of x plus m. At first notice the mapping is denoted as endomorphism. What is the endomorphism? We all of us know endomorphism is an isomorphism, and not only isomorphism, this is also automorphism. That means endomorphism of a vector space is always linear map from vector space to vector space. Obviously this is operator because this is vector space to map itself, because this is not only isomorphism, this is also automorphism. That means this mapping is 1 and on to both, and the mapping is defined as Tm fx equal to f of x plus m, where for all f belongs to V. Then we have to find the dimension of the vector subspace of this endomorphism, which is denoted as the set span of Tm where m belongs to Z. This question is similar to this question which I had discussed in my previous video and which had come in NBSM PhD exam. Notice this question. And if you don't see my previous video, at first I will highly recommend you, please see my previous video. Then today's video would be so easy. Notice here, since the vector space be real polynomial of degree at most n, that means the basis vector are V is 1, x square up to x to the power n, and here the defined function Tm fx equal to f of x plus m. For previous type of example which I had discussed in my previous video, which had come in NBSM 2021 exam, at first considered f equal to 1. Then Tm1 would be 1. Now consider f equal to x. Then Tmx would be x plus m. Now consider f equal to x square. Now find the value Tm at the basis vector x square, which is equal to x plus m whole square. and this would be continue. Then consider f equal to x to the power n, then Tm x to the power n equal to, this would be x plus m to the power n. And notice here x plus m whole square means x square plus 2mx plus m square, and this is also be binomial expression. Just break that down. Here we have to find in the question span of Tm. That means the method is just find the matrix of linear transformation of this Tm. The matrix of linear transformation Tm is, since the basis vector is 1x x square up to x to the power n, that means obviously the matrix would be n cross n times n cross n. Here notice here would be Tm1, Tmx, Tmx square up to Tmx to the power n, and here 1 x square x cube up to x to the power n. And here Tm1 means, had noticed 1, that means 1, and other part would be 0, and Tmx means x plus m, that means this would be m, and the coefficient of x is 1, that means this would be m1, and other would be 0, and Tmx square would be x square plus 2mx plus m square, that means this would be m square 2m, and coefficient of x square is 1, 0, this would be continue, and Tmx to the n would be x plus m to the power n. That means if we break the binomial series, then this would be m to the power n, and here put the value, then last term would be 1. Just take the binomial series. Then since diagonal is 1 1 1 1, so just break the matrix, then this would be at first identity plus just common m, then this would be m times since I have common m, so this would be 0 0 0, here also 0 1 0 0, other part would be 0 0 2 0, other part would be 0, here also would be 0. Means here I have common m, so here would be n, and here then this would be 0. Are you getting? Now common m square from this matrix, then this would be similar to m, this would be 0 0 0, other part would be 0, and here 0 0 0, other part also would be 0 1 0 1, and other part also would be 0. Sorry, here also 0 because I have common m square. This would be continue similar type, and here also would be 0 0 0, and here m square would be such type, here n m, and here would be nc2 m square. That means m square, if we common m square part, then this would be nc2 and other part would be 0. Are you getting? similarly this would be continue, and the last term would be m to the power n, and m to the power n only this part, and other part would be 0. That means 0, 0, 0, 0, 0, 0, 0, 0, 0. This would be continue. Here m to the power n and other part would be 0. Notice this is the linear transformation of the mapping Tm. Are you getting? And here notice m square m to the power n always be linearly independent. So span of Tm where m belongs to integer is n plus 1. Are you getting? I will say one example which had come in GATE exam. The question is, let P2R be the vector space of polynomial of degree at most 2 over the field R, and consider a linear transformation T from P2 to P2 defined by T of A plus Bx plus Cx square equal to A plus B plus B minus Cx plus A plus Cx square. Now consider the following statement. Option 1, the null space of T is set of those elements which contain alpha times minus 1 plus x square where alpha belongs to R. Second, the range space of T is spanned by the set 1 plus x square comma 1 plus x. Option 3, T of 1 plus x equal to 1 plus x square. Option 4, if M is the matrix representation of the linear transformation T with respect to the standard basis 1x square of P2, then the trace of the matrix M is 3. That means the question is about same. We have to find matrix representation with respect to the basis, and here the linear transformation defined as such type. Here the mapping T from P2 to P2, this is also linear operator, and the mapping is defined as T of A plus Bx plus Cx square equal to A plus B plus B minus Cx plus A plus Cx square. Since T has defined from P2 to P2, that means the basis vector are 1x square. Then T1 would be, here this is 1 and B would be, for 1 B and the value of B and C is 0. That means this would be 1 plus this is 0 plus 1 times x square. That means T of 1 equal to 1 plus x square, and T of x equal to, here the value of B is 1 and the value of A and C is 0. That means T of x would be 1 plus x and other part is 0, and T of x square would be, here the value of C is 1 and other value of B is B and A is 0. That means T of x square would be only C equal to 1. That means T of x square minus x plus x square. This is the image of this linear transformation. Are you getting? For the matrix representation with respect to this basis is, would be, here would be T1, Tx square similar to before, and here would be 1 x square, and the value of t of 1 equal to 1 plus x squared, that means the matrix representation would be 1 0 1, and since t of x equal to 1 plus x, that means the matrix representation, the column vector would be 1 1 0, and here t of x squared is minus x plus x squared, that means this would be 0 minus 1 plus 1. Are you getting? Oh well. This is the matrix representation of this linear transformation. Now, and after row reduction, the value would be 1 0 0 1 1 0 0 minus 1 0. This is the row reducing from, and from this transformation, this is the pivot and this column is free variable. Since these vectors are free pivot, so range space contain this vector, that means range space contain this vector 1 1 0. Are you getting? And here the question, the range space of T is spanned by the set 1 plus x square comma 1 plus x. Since range space contain this vector, so obviously this is actually the set containing 1 plus x square comma 1 plus x. Are you getting? That means obviously option 2 is a right option, because here it has indicated the range space of T is spanned by the set 1 plus x square comma 1 plus x. This is right option. And notice option 4 also right, because option 4 is wrong option, because here has indicated if M is the matrix representation of T with respect to the standard basis 1 x square of P2, then the trace of the matrix is 3. Notice this is the matrix representation of this basis 1 x square of this linear transformation, and notice here the trace is 2. So this option is wrong option. Now I will see option 1. Here has indicated the null space of T is contain alpha times minus 1 plus x square, where alpha belongs to R. We have to find the null space of this linear transformation. Since here this is the pivot, and this column is free variable, obviously this set contain non-zero null space. For this, consider this is 0. That means obviously alpha plus beta equal to 0, and beta plus gamma minus gamma equal to 0. That implies beta equal to gamma and alpha equal to minus beta. Therefore, null space contain the vector alpha equal to minus beta, and beta equal to gamma. Since beta equal to gamma, therefore we can put here this value also. That means this vector would be minus gamma, gamma, gamma. Therefore this set actually contain such type gamma times minus 1, 1, 1, where gamma be any number. Therefore, obviously null space contain gamma times minus 1 plus x square. Therefore, the first option is a right option. Are you getting? And third option indicate t of 1 plus x equal to 1 plus x square. That means we have to find t square with the vector 1 plus x. This is the matrix representation of this linear transformation, and for this actually we have to find t square 1 plus x. Then at first just find t of 1 plus x. This would be t of 1 plus x means this matrix times 1 1 0. And this value would be, since we have to find t square 1 plus x, that means just apply again, then this would be 1 0 1 1 1 0 0 minus 1 1. Here with respect to this vector 2 1 1, and this is equal to, this would be 3 0 3, which is actually 3 times 1 0 1. The corresponding vector with this vector would be, this is 1 and this is x square, that means 3 times 1 plus x square. That means t square 1 plus x would be 3 times 1 plus x whole square. In the third option has indicate t of 1 plus x equal to 1 plus x square. This is a wrong option. That means only option 1 and option 2 are right option. That means 1 is right. Only option 1 and 2 are right, because in the question has indicate which statement are true. Are you getting why the matrix representation is very important? If you know the matrix representation clearly with respect to the basis, then you will evaluate easily the null space of any linear transformation, range space of any linear transformation, trace, any part. Are you getting? Well, today I will stop here. In my next video I will discuss other interesting question which had come in different type of comparative exam, because actually linear algebra is very important and very for not only comparative exam, higher study also. See you soon. Stay safe and stay positive always. Thank you so much.